All right, so today's lesson is going to be in a little bit of a different format, and that is because we're going to be utilizing some technology. And so I want us to be able to kind of see my steps as I do them. Now, we do have to get a little bit of background before we can start trying to use our technology. So this is going to be 3.7 and 3.8. So remember when we talked about matrices, we said that the whole reason that we want and like matrices is that's actually going to give us an additional way to be able to solve systems of equations. And up until now, we've done a bunch of operations with them, but we haven't actually used them to solve anything yet. So that's what we're going to talk about today. Now, first, before we can kind of start doing that, we do have to have some background. So the first thing that we need to talk about is the determinant. Now, the determinant is just going to be another operation kind of that we can do with any square matrix. So any square matrix. So remember that means that our rows and our columns have to be equal. Now, I'm going to show you what that looks like for a 2x2. But realize that you can find them for bigger things like a 3x3 or a 4x4. We're just not going to do those by hand because the algebra or kind of the steps to do that is really long. And so we're going to let our calculator do that for us. However, we do at least want to look at what that means for a 2x2. So the notation that we use is either going to be the DET, which stands for determinant of A. Or the other way that we can see that is it's going to kind of look like absolute value bars around our matrix. So again, using those same absolute value bars now instead of our like grouping symbols, I have matrix A, B, C, D. Now, to do our determinant, we're going to do kind of what I call the fish. So we're going to do A times D. So this is going to be multiplication. Then we're going to subtract B times C. So notice that it kind of creates a little fish. And so that means that my determinant is going to equal A times D minus B times C. And that's going to be true for any 2x2 matrix. So let's look at an example of that. So if I had the 2x2 matrix of 5, -4, 8, 9. Now remember that our absolute value looking bars mean that I am finding the determinant in this case. So remember that we're going to do, in this case, 5 times 9. Then we're going to subtract -4 times 8. So let's go ahead and write that out. So we would have 5 times 9 minus, that's really important, it is subtraction, -4 times 8. So simplifying, we would get 45. And because we're subtracting a -32, it's going to become addition. And we would get 77. So that would be my determinant for that one. Now let's look at one more. So again, finding the determinant, we have 0, 6, 4, -11. So again, we're wanting to find the determinant. So this time we're going to do 0 times negative 11 minus 6 times 4. So we get 0 minus 24, which gives us a negative 24. Now, like I said, the whole reason that we want to use matrices is to be able to solve systems of equations. And so we do need what's called a coefficient matrix. And so hopefully by just the name of it, we can kind of guess what it's going to entail. It is going to be our coefficients, but they're going to be inside of a matrix. This is going to be a matrix that contains only the coefficients. So looking at that, if I had something like the system of equations, negative x plus 2y equals 4, and 5x minus y equals 2, my coefficient matrix, which I'm going to let be capital C, would equal negative 1, 2, 5, negative 1. So it's just those numbers that are in front, because remember that those numbers are our coefficients. And the reason that that's important is because looking at the determinant of a coefficient matrix, it can actually tell us how many solutions we're going to have. So if my determinant of C, so remember DET stands for determinant, if I can find that determinant and it does not equal 0, I'm going to have one solution for my matrix equation. If I find the determinant of C and it does equal 0, there's actually going to be no solution, or it could possibly be infinite solutions. And it could be either one. And just by looking at the determinant, we're not going to be able to tell which one of those it is, but it does give us some good information when we start trying to solve. We can know then if our matrix equation is going to be solvable or not. All right, so next up, just like with any of our numbers, we have what's called an identity matrix. Now, an identity matrix is special because it has some nice properties. So an identity matrix is going to be similar to the number 0 if we're talking about adding, or the number 1 if we were talking about multiplication. And what it's going to look like is basically we're going to have 1s along our diagonals and then 0s everywhere else. And we are talking about a square matrix. So I have to have the same number of rows that I have columns. So this would be an example of an identity matrix for a 2x2, an identity matrix for a 3x3, and that's going to go on forever. So if I have 1s, so continuing, that's what my little dots mean, the same pattern, I'm going to have 1s along my diagonals, and then I'm going to have 0s everywhere else, however many 0s that we have to have, and so forth. Okay? Now, the reason that we need our identity matrix is so if we think about addition. If I were to ask you, what is the inverse of addition? We would say that it is subtraction. And we know that two things are inverses of one another, so like 2 and negative 2, because they add to give us that identity, which is 0 for addition. Likewise, if I asked you what is the inverse of multiplication, we should say division. And kind of the same idea, if I multiply, say, 2 by 1/2, it's going to give me the identity, which is 1 for multiplication. And so our matrices have inverses as well. And those are special matrices that, if I multiply them together, I'm going to get the identity matrix, which we're going to label with a capital I. So if I have A and I multiply that by A inverse, so that's what the little -1 means, I'm going to get the identity matrix. But now remember that my matrix multiplication is not commutative, so my order does matter, which means that I would need to check it going both ways, A times inverse of A and also inverse of A times A, so on both sides. And they both have to give me my identity matrix. And that's what would determine if something was an inverse or not. Now, we're not going to get into how to find inverses. If you were to take a college level course, you would get more into that. But I do want us to know what they are so that way we can use them. So lastly, our last definition before we kind of get into a little bit of the work. So the whole reason why we've been learning about matrices, we've finally been able now to combine everything together, is because we have this thing that's called a matrix equation. And it is going to be an equation that contains matrices. And we're going to use it to solve systems of equations. So now let's look at an example of that. So if, let's say, we had the system of equation, -x plus 5y equals 3, and 2x minus 7y equals 1. And I wanted to write out the matrix equation. So first off, we would start with our coefficient matrix. So that's going to be -1 because that's the coefficient of my x. Going across, we have 5, then 2, -7. And it is going to be important to make sure that all of our variables are lined up. If they're not, then you can just do a little bit of rearranging and add or subtract anything that we need to. Next, we're going to have our variable matrix. And then lastly, we're going to have our constant matrix. And so that would be a matrix equation. It is comprised of matrices, and we could then use that to solve. So we have our coefficient matrix, our variable matrix, and our constant matrix. Now, like I said, we want to then use that equation to help us solve. So let's look at an example where we actually try and solve something. So let's use matrix equations to solve -x plus y equals 3, -2x plus y equals 6. So our first step is going to be to find our matrix equation. So I'm going to set up our equation. So I get -1, 1, -2, 1, x, y, and 3, 6. And basically, we're going to let our calculator do a lot of the work for us from here on out. So let's think. Again, we're trying to solve for x and y. And just like any other problem, if I had 2x equals 6, I would want to divide by the 2, because that's going to get rid of that 2 that's in front of my variable. In this case, we have a matrix in front of our variable matrix. So in order to get rid of it, we have to multiply by something that's going to give us the identity matrix, which, remember, we said is going to be our inverse. So remember that this matrix right here is our constant matrix, or matrix C. So we actually need to multiply both sides by the inverse of C. And when we do that, it's going to allow us to get rid of, or get our identity matrix on the left-hand side. Because if this is C and I multiply it by C inverse, remember we said that the definition of an inverse is that I get the identity. So C inverse times C is going to give me my 2 by 2 inverse. So identity 1, 0, 0, 1. And then I still have an x, y, and that's going to equal now whatever my C inverse is times 3, 6. Now, if we needed a little bit of convincing that our identity matrix times our XY matrix is going to make this identity matrix go away, we have learned how to do our matrix multiplication in our last lesson. So let's go ahead and work that out. Now I'm going to show you just so we can all be convinced. In the future, we will not have to work it out every single time. We will just assume that that's going to be the case. So notice that we're going to start in our first row, and we only have one column, so we're only going to do one column. So we would have 1 times x, and then we would do going across our first, down our second, so plus 0 times y. We don't have another column, so that's going to be it. Going down to our second row, we would have 0 times x, again across our first, 1, down our second is y. So then simplifying, well, 1 times x is just x, and 0 times y is just 0, so the y's go away. 0 times x is 0 plus, I forgot my plus sign, so plus 1 times y is just going to be y. So notice that my identity matrix does indeed go away when we multiply that out, which is what we want to happen, because now in our matrix equation, we have our x, y by itself, and we know that if I multiply my constant matrix by my inverse of my coefficient matrix, that's going to give me my final answer. And this is where our calculator comes into play. If you have a graphing calculator at home, you can actually use that. Or if you have an Android smartphone or even an Apple smartphone, there is an app that is called Calc84. And it's actually a graphing calculator simulator. And so that's what we're going to be using today. So on my phone, I'm going to be showing you, maybe. It looks something like this. Let's turn down my brightness. So then hopefully, too dark. Did that help a little bit? Yeah, okay. So looking at this, we're wanting to use this to help us to find this identity matrix and also to be able to do this multiplication for us, which we could also do by hand, but it's nice to let the calculator do it for us. So in your TI-84, there's actually a matrix menu. And notice that it's above our x to the negative first button. And so that means that we have to click second and then our x to the negative first. And that second basically gets us to have any of the little numbers or letters or words that are above each of our buttons. Now we're needing to enter in our coefficient matrix. So if you're in a normal graphing calculator, you would arrow over until you get to your edit, which is what we want. In this case, I can just click on the edit and it will give me the edit. And then if you're in a normal TI-84, you would just click number 1 or click enter on number 1. Here I'm just going to tap it. And we're wanting to enter in our coefficient matrix, which we said is -1, 1, -2. So notice that this is a 2 by 2. Right now, my matrix A is saying that it's a 3 by 3. So I need to change that. So I'm going to enter 2 and then enter, and then 2 and enter. And you would do the same thing on your normal TI-84 graphing calculator. And notice now it gives me a 2 by 2 matrix. And so then I'm just going to enter in those values. So make sure that if you're entering in a negative, you do have to use the negative button. Don't use the subtraction button because it will give you an error. So we're wanting -1, and then I'm going to click enter. Going across, I then want 1. Going down now, I have -2 and 1. So now I have my matrix A, and that's what I'm wanting to use in order to be able to calculate some stuff, okay? But notice that we also need to have stored somewhere our constant matrix, which we don't right now. So we're going to go back to our home screen. So second, and then mode is quit. So there's a little quit above, so that takes us back to our home screen. I'm going to go second, back to my matrix screen. I'm going to edit, but this time I want to edit matrix B, and I want to turn that into my constant matrix. So that is going to be a 2 by 1, and it gives me a 2 by 1. So then I'm going to have 3 and 6. So now I have both of the matrices that I need. So a second and quit again. Okay. Now, the nice thing about that matrix menu is that if I go into that menu again, this is basically going to be where all of the operations and lists and things like that that we need for matrices is going to be located. So notice that we are needing to take the inverse of our constant matrix. So I'm going to go to where it says name. I'm wanting to tap on A. Now notice that it should enter in my A matrix. If you're working on a normal TI-84 calculator, you would just click enter on A, and again, it's going to enter it in on your home screen for you. So then again, going back to that matrix menu, we want to go to our operations, which is going to be under our math. And notice that there's lots of operations. We have the determinant, which remember we talked about just a minute ago. And then there's some other stuff that is kind of above what we need to know. You can take the absolute value of a matrix. You can do lots of stuff here. However, remember that we're just needing to take the inverse and multiply. So those are actually just going to be on our home screen. So going back to my home screen, notice that button that we've been using for our matrix, if I just click on it without first clicking second, it gives me a little negative first, which means I'm going to take the inverse. Then I'm wanting to multiply that. So I'm just clicking my normal multiplication button. And then I need to multiply that by my constant matrix, which remember we stored in matrix B. Then if I click enter, it gives me a nice, pretty answer. And what's nice is that's actually the answer to my system. So we got that our xy, if we multiplied that out, is going to be -3, 0. And what's nice about that is that we can, if we just work our way straight across, so our x's are going to be -3, our y's are going to be 0. So we could write it out with our equations, or remember we want to write it out as an ordered pair. That would be our final answer. And this is going to work for any size of a matrix. So the algebra for a 2x2 wouldn't be super hard to do by hand. However, if you have anything that is bigger than that, it's not going to be super fun to try and do all of those calculations by hand. And so that's why we want to go ahead and let the calculator do it for us. So on today's homework, you're actually going to get this little worksheet, and you can do it digitally, or you can use the hard copy if you want to use the hard copy. And so it kind of takes you through the process. So notice in our first step, it wants us to line up our variables. So notice right now, this first one looks like all of our other ones have, but this second one doesn't. So you would need to move that y over and rewrite it. Then you're going to write out the equivalent matrices. So basically, in other words, this is creating that matrix equation. And then it adds in another step of wanting to separate out the variables. You can kind of skip that one because for us, we went ahead and did that all in one step when we wrote out our matrix equation. And then lastly, it wants you to multiply by the inverse to solve for x and y. And what's nice is if you look down here at the bottom, if you forgot, it does give you some nice instructions. So on this first example, it is a 2x2. So it's going to be very similar to what we just did. And then on the next one, it's actually a 3x3, so it's a little bit bigger. But the process is going to be the same. You're just going to enter in a bigger matrix on your matrix screen. There also is a key attached on Canvas. So if you want to check your answers once you do it, you will be doing it that way.